Worked example 13a. In this example, we are required to determine the augmented matrix of the following set of linear system. In order to determine the augmented matrix, we first have to find out how many variables do we have. In this instance, we have only one variable, x1. So we are going to have an augmented matrix that is going to have two columns. How do I derive that I'm going to have two columns? I have only one variable and I know that there's going to be another column for my solution set. And how many rows am I going to have? I'm going to have 3 rows coming from first equation, second equation, third equation. So the number of equations that you have will determine the number of rows that you have. So the augmented matrix for this equation will be minus 2 coming from 2 here, the minus 2 here, 3 coming from my 3 here, 9 coming from my 9 here, then the solution set 6, 8, minus 3. Therefore this is now becomes my augmented matrix. The second worked example 13b. In this example, you want to determine how many columns. First, determine how many columns you are going to have in your augmented matrix. You are going to have, you check your variables and you check, I see my variables are sequentially numbered. I see there's x1, there's x2, there's x3, there's x4. So I'm going to have 5 columns, one for each variable, then the last one for my solution set. So how many rows am I going to have? I'm going to have 2 rows coming from the fact that I have 2 equations. Therefore, just to make it easy for you for the first time, I'm going to denote each column by its variable. For instance, I'm going to have column for x1, column for x2, column for x3, column for x4, then my solution set. I'm now going to only work with the first equation. For x1, I have 3 coming from the 3x1. The constant 3 coming from the equation 3, first equation 3x1. Then I have the constant 3. x2, I don't have x2 in my first equation. So what do I put? I'm going to put a 0. I will put a 0. This stems out from the fact that 0 x2 is equals to 0, which explains why there is no x2 in this equation. And therefore, my constant for x2 is 0. This 0. That's why I've put it here. Then x3. x3 is minus 1. Where did I get the minus 1? Minus x3 is the same as saying minus 1x3. Therefore, minus 1 is this minus 1 that I've put there. Therefore, then x4. On x4, I'm going to put 6 coming from here. Then on the solution set, I have 0. Then I go on the second equation again. I don't have x1. Then I know from the first equation that whenever I don't have that variable on my equation, then its constant is 0. Then x2, 2 coming from here. x3 minus 1 coming from here is also explained here. The fundamental principle is also explained here. Then x4 minus 5. Then my solution set 2. You don't need to write these variables when you write augmented matrix. You are not required to write this variable. I just put this variable so that it can be easy to understand. But now if I write my augmented matrix in the way it's supposed to be written, it's only going to look like this: 3, 0, minus 1, 6, 0, 0, 2, minus 1, minus 5, minus 2. Therefore, this is now my augmented matrix.